Right here, so far we have seen how things are stored in memory in MIPS. We've seen basic arithmetic operations and basic loading and storing operations. Today we're going to have a look at arrays and a little bit at pointers. So just before we do that, let's have a brief recap and remember that we have alignment restrictions in memory, and that means every address is byte addressable, so we can get to every address and get the byte out of it. Every multiple of 2 is a half word access because the half words take up 2 bits of memory or bytes of memory, so they need 2 registers to be stored at. And word addresses must be multiples of 4 because they take up 4 registers or 4 addresses in memory because they're 4 bytes long and each address is a byte. So with that in mind, let's have a little think about how we might store arrays. An array is a sequence of items contiguous in memory. Now, what does that mean? Well, contiguous means to be next to each other. So, next to each other, they have to be stored in a row in memory. So let's have a look at some code that sets up an array. You see here, where we've got the primes label, and we're storing 4 bytes. Now, all you need to do for something to be stored as an array is to write it out with commas between it, and that will let MIPS know this is something that needs to be stored in adjoining registers, as it were. And you can see here that this gets stored in the first address, and you have 2, 3, 5, 7 stored in the neighbouring addresses. So that's easy enough for bytes, but what about for words? Well, with words it's much the same, you just change .byte to .word. However, then you need to be aware that you're taking up a lot more memory because each of these words needs 4 bytes of memory, so they need 4 addresses to be stored at, but you can still see they're stored at the adjoining memory addresses. So the first one takes up 0 up to 3, and then the next one is 4 to 7, and then it's 8 to 12, and so on, or 8 to 11, sorry, and so on and so forth. So you can see how this idea of them being contiguous in memory is set up within the memory of MIPS. So let's see how we would actually start manipulating that. Well, if we want to load out the first element of an array, that's pretty easy because we just do it the same way that we would for any word. You just use the load word instruction, you give it the register you want to store it, and you give it the memory label, in this case primes, and that just says the first one, the one that's stored at the location primes, that's going to be the first element of the array, and we'll store that at T0. So that's easy enough. But how do we get the rest? Well, then we need to turn to offsets. So we've seen offsets before, and you can see here the way it's been set up is that we're loading into T0, T1, T2, T3, and we're just adding on to the primes label the offset. So you'll need to remember that words need to be incremented by 4 because the offset refers to a number of bytes. So plus 4 means 4 byte spaces up, plus 8 the same, plus 12 the same. And this increments enough that we can get to the next word in memory, which is stored 4 addresses above the previous one. And that's the same as using in Java as you would like .get I. This is the same as doing .get 0, .get 1, .get 2, .get 3, and then storing them in variables. And that's the syntax for it. It's load word r label plus offset. So you really need to remember that the count bytes, so they're multiplied by 4 in this instance. We can't just say index plus 1 as we would be used to doing in Java. It needs to be plus 4 for words. For bytes it would be fine to be plus 1, but for words it needs to be plus 4 so that we increment the addresses properly. So at the start of this lecture I mentioned something called pointers, and that's a very literal name. A pointer is something that contains a memory address that points to the memory location of the thing you actually want. So a pointer could be a variable, it could be a register, it could be a memory location, whatever it is. It's just something that points to where the actual thing is stored. Now you'll have used these without knowing it, so don't worry too much about them. You just need to know the syntax. But for example in Java, when you have a primitive type like int or byte, that's passed around by value, but when you have a larger object that's a bit more complicated, then that just contains a reference to the actual thing where it's stored. So that's an idea of a pointer, something that tells you where to go to find the thing you want. So in this case, let's have a look at how you would use them. So this instruction, load address A0 to primes, that's setting A0 to be the memory address of primes. It's not being set to the literal value stored at primes. It's telling A0 to be equal to the address where primes is stored. And you can see that in this diagram here. A0 is not equal to 2, it's equal to the memory address. So if we wanted to load things into an array using these, this is the way we would do it. So now that we have a pointer in the form of A0, you would load the word into S0 from A0, and that would say that A0 is the 0th position of the array, and I want you to take the word from that position and store it in S0. Now, one thing about pointers that's a little bit weird in MIPS is that you need to put brackets around them. That tells MIPS that this is something you need to treat as a pointer, not something to treat as a register or a variable or anything like that. So how would we get the rest of the array using a pointer? Well, it's very similar to our offsets, but the thing you need to remember is this sort of strange syntax. It's a little bit weird, I think, but you put the offset and then the brackets and the pointer itself. So 0, A0 tells it that it's the first position at A0, 4 tells it's the second position, or the one 4 bytes long, same with 8, and same with 12. And again, these are multiplied by 4 so that we have the size of a word. And yeah, you can see down here, this is how it's laid out in memory, or this is what the computer understands. When we do 12 A0, it's actually looking to the address plus 12. Okay, so I think that's everything for today. If you have any questions about any of this material, please do feel free to let me know. I'll be doing some practical exercises, so don't worry if you haven't gotten your head around all this just yet. I'll be doing some exercises using Mars to show you how you manipulate and create arrays at your whim. Thanks.